Okay, welcome. It is right at time. We are going to get started with track E, learning and facilitating. We're excited for three really great lightning talks this afternoon. Our first lightning talk is going to be a pre-recorded talk from Kyung-Won Ko, who gave one of our keynotes this morning. And it will be co-teaching and the role of school librarians in facilitating maker learning in schools. So we will go ahead and get started with that one.
Hello, everyone. I'm Dr. Kyungwon Ko, Associate Professor and Director of the Champaign-Urbana Community Fab Lab at the University of Illinois at Urbana-Champaign. My lightning talk in this session focuses on maker learning in formal school environments, especially the role of school librarians. This presentation is part of my previous IMLS-funded study titled Learning in Libraries, Guided Inquiry Making and Learning, in which I collaborated with Norman Public Schools in Oklahoma to integrate maker learning into standard curricula across elementary, middle, and high schools. Let me begin with the background of this research, maker learning in schools. Given the power and benefits of making as a learning approach, now supported by numerous research studies, it is a matter of equity that every learner has the opportunity to engage in maker learning through school education, rather than limiting it to those who can afford to learn and create in out-of-school environments. However, efforts to incorporate maker learning and more importantly, to develop maker mindset and a maker culture in schools have revealed several challenges. For example, how can you preserve the interest-driven and creative spirit of maker learning while operating within a standards-based curriculum? Also, the logistics of incorporating making in schools are complex. Challenges include prescribed standard, rigid schedules, teacher-student ratios, budget and staff time constraints. This study addresses these broader challenges of implementing maker learning and more generally any learner-centered approach within formal school settings. It does so by focusing on the role of school librarians and exploring co-teaching as a specific instructional technology approach. So here are quick definitions of key terms. In this research, we define maker learning as a hands-on learning approach through which learners create, design, tinker, experiment, and share projects using a range of technologies. Co-teaching is a specific style of instructional collaboration and partnership that occurs when two or more educators bring different expertise and assume complementary roles to plan, teach, and assess together with shared responsibilities. So the goal of this study was to deepen our understanding of the role of school librarians in co-teaching learner-centered instruction, such as maker learning with classroom teachers. We investigated how educators taught 35 maker learning and inquiry units within a public school system over 3 years. And using interviews and field observations, the research involved 25 educators, including school librarians and classroom teachers from different disciplines, such as social studies, science, language art, and math. Each school had at least one school librarian holding a master's degree in library and information studies. Let's dive right into the key findings. The findings show that the role of the school librarians in co-teaching extended through all areas of the instructional process, including working with classroom teachers on co-planning, co-implementing, and co-assessing the maker learning unit. The librarians also took on the role of coaching teachers in their areas of expertise. I'll highlight just a few key findings, and I encourage you to check out the full paper published in School Library Research. I'll share a QR code to the article at the end of this talk. Co-planning. So a significant part of the co-planning occurred through co-planning. Librarians said it was very important to be involved from the beginning, the planning process with the teachers. During the co-planning prior to the unit, school librarians did lots of scheduling, designing units, creating instructional documents such as maker journals and rubrics, and curating resources for student research and making. Throughout the unit, unstructured and on-the-fly planning continued between the teachers and librarians for making changes throughout the semester. Co-implementing. So during the implementation of the unit, the school librarians led instruction in their areas of expertise, such as maker technologies, led exploratory sessions in their school library makerspaces, and delivered information literacy instruction lessons. And they also provided individual and small group assistance for the learners, as well as classroom management assistance throughout the unit. In their informal and individual coaching, the school librarians focused on figuring out when students truly needed one-on-one help versus when students could learn best by experimenting and trial and errors on their own. So by stepping in at the right moments, they guided the students through common challenges and helped them keep going. We found that many of the effective teaching methods used by school librarians in this study were based on cognitive apprenticeship. So cognitive apprenticeship involves an expert helping a less experienced person by providing structure and examples to support learning. So this is a social learning theory where learning happens through social interactions and guidance, such as scaffolding, modeling, mentoring, and coaching. For example, a school librarian described how she modeled problem solving when the technology doesn't work. So she said, my preference is just work through it with kids and use that as a model for a growth mindset and how to deal with the struggle and just be honest and say, hey, my audio is not working. Let's see, I'm going to think through this, what works and what doesn't. Classroom teachers highlighted how helpful it was to have another experienced educator in their classroom when they implemented a highly personalized learning program in their classroom of 20 to 30 students. The teachers and librarians also worked together on assessment, so co-assessing took place before, during, and at the end of the unit, and both formal evaluation and informal monitoring and feedback were used. One noticeable observation was the educators modified existing rubrics because initially students tended to select an easy and safe maker project to earn a good grade rather than a more risk-taking and innovative project. So the revised rubric placed more emphasis on the learning process and the risk-taking aspect. So there are many other interesting findings. And again, I encourage you to check out the full paper. And this study suggests that co-teaching and the role of school librarians significantly mitigate challenges of learner-centered instructions in school, including maker learning. So here are some of the implications we have. School librarians are encouraged to develop their expertise in maker learning, emerging technologies, and learner-centered instructional approaches and methods, such as co-teaching and cognitive apprenticeship. Classroom teachers should seek out and embrace co-teaching opportunities with school librarians to enhance learner-centered instruction. And finally, schools must hire qualified school librarians to support creative learning and properly equip students for our fast-changing and complex society. Administrators should focus a culture of instructional collaboration and offer professional development that brings school librarians and teachers together. Improving our public formal education takes a lot of work and persistence. And although I'm not saying that maker learning is a silver bullet, in my years of working with schools, I've seen how For some students who otherwise struggled, a maker program, a maker space become a bright spot in their lives and the reason they wanted to go to school. So thank you to everyone who has put tremendous effort into this area. And thank you for joining us today. Please feel free to reach out if you have any questions.
Great. Okay. Now we will welcome Soo-Hyun Kim, who will be presenting Family Makers, promoting engineering learning for children and caregivers through online making programs at rural libraries. So Soo-Hyun, take it away.
Can you hear me okay? Okay, my name is Soo-Hyun Kim. I'm currently an assistant professor of library and information science at Indiana University in Indianapolis. I'm really excited to present our work on behalf of our amazing research team. Um, so makerspaces are informal sites for creative production, right? And while makerspace generally refers to physical spaces where people have access to tools, expertise, and facilitation, it also includes the intangible communities and programming for creating and sharing. So in that sense, I argue that makerspace can exist without a physical space if the ethos of creating, collaborating, and sharing is supported. So makerspace and my work are understood broadly from dedicated physical space to small-scale services and programming in both in-person and online settings. There can be many goals for library makerspace, and one of the goals that we are looking at is to broaden STEM learning opportunities. And there's been continuous efforts to broaden STEM participation at public libraries. However, research that leverages the online space to strengthen public libraries' maker programming is rarely examined. So we contend that an online making program offering take-home kits, hotspots, and tablets for community members to participate via video conferencing software has the potential to expand and broaden STEM learning at rural libraries. And the study I'm presenting today, called Family Makers, builds on this rationale with the goal to develop an online engineering program for children and parents that's facilitated by rural libraries. I'm the PI of the study, and it's in collaboration with University of Cincinnati and 7 rural libraries. We also collaborate with engineers who grew up in rural communities and the Association of Rural and Small Libraries. The study is also funded by IMLS. These are the 7 rural library partners who collaborated with us to co-design and facilitate Family Makers online program. Since Family Makers is an online program, we provided tablets, hotspots if families needed them, and our target was caregivers and children 5 to 10 years old. There were a total of 6 programs, each lasting for a little over an hour. And we had 3 goals. We first aimed to develop a field-tested online engineering program tailored for rural libraries and rural residents. And by doing so, we aim to develop children and parents' understanding of engineering and participation in engineering practices. And also expect librarians to develop new understanding of engineering and develop confidence in facilitating engineering program. Our work is shaped by culturally relevant pedagogy and constructionism to focus our engineering programs on the everyday making activities in rural communities. And so we integrated engineering within children's community contexts, providing challenges that stem from relatable experiences. We also made connection to broader engineering community by recruiting 10 engineers who grew up in a rural community. They created a day in the life of a rural engineer video using GoPro kits that we sent, which were utilized during our online sessions. And engineers also came into our last session to share what they do and celebrate what families have made. There are 3 phases in this project. In phase 1, we aim to first understand challenges rural librarians and families experience in supporting children's engineering learning. Then we explored how these challenges can be addressed through rural families' funds of knowledge. Funds of Knowledge is a theoretical framework that takes a strength-based approach to consider learners' home, cultural, and everyday experiences as valuable learning resources. And for the sake of time, I'll just quickly share one of the main challenges and funds of knowledge we found in phase one. The main challenge for supporting children's engineering engagement that both librarians and caregivers mentioned were their lack of confidence and knowledge in engineering. Overall, there was a lot of concern and even fear and anxiety around having to support children with engineering learning when they did not know too much or have experience in engineering. However, what was most exciting to discover from phase one was families and librarians' engineering-related funds of knowledge that we leveraged when we co-designed the curriculum. So our analysis showed that participants routinely engaged in household management practices, such as fixing household machines, making home improvements, fixing patio, working on their vegetable gardens and yards, laying tiles, coming up with a creative recipe that utilizes leftover ingredients. So we found that everyday skills and expertise acquired through familiar community and recreational practices facilitated rural children's development of teamwork, system thinking, ethical reasoning, and scientific and mathematical knowledge, which were all essential for engaging in the engineering design process. So in phase two, we co-designed Family Makers online program with 7 rural librarians around these funds of knowledge to create an engineering curriculum that's culturally relevant and engaging. And in phase three, we will focus on dissemination by generating training materials. So for today's presentation, I'll be sharing findings from one of the studies we did in phase two that asked, how did children, caregivers, and rural librarians' perception and understanding of engineering change as a result of participating in Family Makers program? 7 librarians, 14 parents, and 17 children filled out pre and post survey and participated in an interview before and after participating in 6 Family Makers program. For librarians, we additionally collected video records of their participation during 8 co-design sessions. So based on survey analysis, we found that children who participated in Family Makers had increase in their STEM efficacy and attitude. And for engineering and technology specifically, the mean score went up from 4.14 to 4.33. And similarly, parents who participated also had increase in the mean score for engineering knowledge, attitude, and behavior. And similar results were also observed in librarians. And due to small sample size, we only ran descriptive statistics, but these results were still very exciting. And interview analysis demonstrated that prior to participating in Family Makers, children lacked knowledge and experience in engineering. As you can see in these quotes, children thought engineering was just about machines and building stuff. However, after participating in 6 online sessions, children demonstrated expanded understanding of engineering, acknowledged different types of engineering, and saw the relevance of engineering in their lives and how it impacts their community. And for the sake of time, I will not present the findings from parents and librarians, but however, similar findings of their understanding being expanded was observed. So for parents, in addition to having an expanded understanding, they expressed that they are viewing creativity and exploration more positively and shifted to fostering these values more at home. And several participants also noted their perception and confidence in STEM changed. So we see that this is an important learning outcome, as learning ways to support their children will have an impact in how they guide and support their children within home environments and everyday life. Now, for librarians, the analysis of librarians' initial interview illustrated that rural librarians had lack of confidence in engineering, as evidenced by some of these adjectives such as nervous, scared, terrified, not sure. However, after co-designing the curriculum and facilitating 6 online sessions, librarians mentioned that it helped them to broaden their view of engineering and provided confidence that they could do engineering. Let me quickly read this interview excerpt from Crystal. One of the lies I tell myself is I'm not good at math, I'm not a science person. But doing these co-design activities and just seeing that it's so wider than this narrow view of it, which made me go, okay, I could do this, and I'm not bad at math. That's just what I tell myself. And I am an engineering person because I engineer stuff all the time. I just don't call it that. So our work highlights the effectiveness of a culturally relevant engineering curriculum co-designed by library staff. By leveraging families' cultural practices of making and funds of knowledge from everyday life, it fostered knowledge, attitude, and understanding of engineering among rural children, parents, and library staff alike. Building on these findings, the study suggests several implications. Our study showed that engineering learning can occur in remarkably non-engineering related activities in everyday life. So to lower the entry barriers of patrons who might be hesitant to participate in an engineering program, we advocate to expand our understanding of what counts as engineering to include problem-solving skills found in everyday rural life, such as cooking, gardening, DIY projects, and sports. And recognizing that engineering knowledge is not confined to professional expertise, but can be also found in everyday familiar practices, can help librarians in designing library-based engineering program. Sorry. And with this in mind, we invite future research to further investigate different ways of developing culturally relevant engineering learning experiences within public library making programs. And if you want to know more, please visit our project website. And finally, I would like to acknowledge that this work is developed on many, many people's work. And lastly, I would like to thank IMLS for funding this study. Thank you.
Okay, Soo-hyun, thank you so much for that great presentation. We will have time at the end of the session for questions. I know I already am bubbling up some questions for Soo-hyun's amazing project, but we will move on to the next and last of our lightning talks in this session, and it will be by Michael Tizenbaum and Nathan Holbert. Connected Spaces, a technological framework for fostering collaboration by linking novice makers with mentors and peers. So I will hand it off to our presenters.
Thanks, all. Just apologies that Nathan Holbert couldn't make it, so I'll be speaking on behalf of both of us today. And this is some work that we've been doing. It's funded in a large part by an NSF DRK-12 grant. So shout out to them and thank you for all of that. And so the sort of rationale behind what we started this project originally during the pandemic, and understanding that it was difficult for people who were doing making to potentially connect with others because we were all fairly isolated. And it rose up some questions for us about, well, there's lots of places where people perhaps are not always connected together, might feel like they're on an island, might be looking to understand how they can develop their sense of identity and community within making, and how we could sort of think about developing tools and structures that could support this kind of learning at a distance, this more distributed notions of community and expertise and mentorship. And so, based on that, we began building a set of tools which we have called connected spaces. Hopefully this turns, there we go. And connected spaces is essentially a technological toolkit and design framework to connect geographically distributed middle and high school learners interested in fabrication and making to like-minded colleagues. Now, that sounds a bit vague, but really what I'm going to do now is show you how some of these tools work and give you a sense of how we envision, or actually through our work, how some of this has come together. So the first one is a dashboard. And on the surface, it's fairly simple. You know, we've seen a lot of sort of dashboardy kind of things happen before in makerspaces. But there's a couple things that we did here that are perhaps a little different. Um, we give, so the students get to put their name in, a little bit about themselves. You'll also notice the pictures on the right, we allow for a lot of artistic creativity for kids to express who they want to be and how they want to show themselves to others. Um, because we recognize that, within these sort of communities, self-expression, being able to represent yourself as an individual is critically important. So what happens is you basically create your bio on the left side here. And another piece to it too, I don't know if my mouse is showing up, but you choose affinities. And affinities are a little different than, say, badging systems. Badging systems are often things that you must earn. And we've found, and other research has shown, that actually badging systems can be really problematic in terms of giving people a sense of identity and belongingness, because there's some arbitrary thing that says you haven't qualified to talk about these things. You don't get to see yourself as someone who does LEDs because you haven't crossed some sort of threshold. But there's actually a lot of stuff in learning sciences literature that it says you don't have to be an expert to be useful to help people learn or for you to learn yourself. We actually just want you to engage. So we allow it to be affinities. Kids choose the things themselves that they are interested in, that it says, hey, I am interested in talking to anybody about any of these topics at any point in time. So you may not be an expert in LEDs, but you want to talk. If somebody wants to talk through their project and say, hey, I just want to talk through what I'm doing with my LEDs, are you available to do that? That to us is actually far more empowering and helps support those kind of critical ideas around identity and belongingness in these spaces that badging systems are often exclusionary around. Um, and so as each person does this, all of their individual profiles show up on a large ambient display in each space. And the way we've designed it is actually we can have multiple spaces linked together. So you may have a library in one part of the city and a library at the other, and those kids may be doing things that are similar or complementary in different spaces, and all of the profiles show up in both spaces. And so that lets kids see that, oh, there's others doing work similar to them. There's other kids doing work that kind of connects with them. If I need help, then I can reach out perhaps to even somebody in another space. Now, how you reach out and the kind of work you can do can often be challenging when there people are in different spaces. So don't worry, I'm going to show you a little bit about how you could do that as well. Another way that we've been looking at for supporting students in developing, this sense of community, this sense of how we belong, is making progress. It's a tool that allows you to really quickly record anything at any point in time, and either as a static image, as a video, you could add speech to it and captions, right? And publish it to a display that's located in each of the spaces as well. So it's this kind of like ongoing sort of like quick little feeds about what everybody's doing or about what you're doing, as opportunities to connect and reflect and say, oh, look, somebody else is doing a project that's very similar to mine. That is another opportunity for me to talk and connect with them, right? And we've been adding some multimodal AI supports to this as well. Students could ask to generate a slideshow of their project. So like all the things they've done over time, but we've also seen that it's able to pick out things that kids are working on, like LEDs or particular wires. And so we're looking at seeing if this kind of tool could be like, I want to know everybody who's working on things with proximity sensors. And can the AI look at the images across all of these and go, yeah, actually, this student and this student and this student's work seems to indicate they're working on things that are similar to you. Should we make a connection between the two of you? And so, ways of other ways of kids recognizing, representing themselves and connecting with their peers. Now, the one thing I haven't really talked about yet is how you connect these kids and these groups going across these different spaces. So one of the other tools we've created is called the Reach Projector. And the Reach Projector is actually this work by one of my PhD students. And what it is it's hard to show over a Zoom, but it's a system that sits over the working table, and it's got a projector and a camera. And what you could do is the thing you're working on, you can place it, as you can see in the top image, under this projection and camera system. And the camera will pick up what you've put underneath and project it in another space anywhere else in the world. And then the person in the other spot in the world can see what you're working on and can put their fingers or put objects on or around the piece that you placed, and the camera in their space picks that up and projects it back in the original space. So now we can have people actually collaborating and working together on real physical objects across all over the world. So we've used this thing to have kids work on debugging projects or talking about their projects with people in Champaign and in New York in real time. We've also had them do it with people in Italy and Costa Rica, right? And so creating real networks of experts and learners working together to debug, connect on their projects. So what this does is we have the first two tools that allow kids to kind of understand how they're connected with others, right? Understand what ways people are working together that may be complementary, ways of finding others when you may be looking for help or looking to talk with someone through your design. And then we have tools like Reach that allow you to actually get together and do the kinds of really hard face-to-face work in much more seamless ways than we've ever seen possible in distributed forms. So I'll go really quick because I realize we're running a little short on time. Um, but we found that this is facilitating new forms of collaborative making, where the kids are able to do these things that we're calling boundary spanning, right? Actually collaborating and debugging and working across physical spaces in ways that otherwise have been largely impossible, right? And that overall, this suite of tools, I could get into it, but we used a combination of a coding scheme we have around computational action and something that Nasir and Cooks have talked about, which is resources for supporting identity and belongingness and within sort of maker or computing spaces, and that the suite of these tools have been shown to actually positively impact kids' senses of identity as being part of an authentic computing community, about being able to feel like the things they're doing are being advanced or being recognized because of these tools. I'm happy to talk more about this, but I wanted to, we've got a fairly quick 10-minute talk. And in terms of libraries for this, what I want to make clear is I think these tools, we looked at it across makerspaces, but libraries are often networks of spaces that are doing similar projects, maybe even at the same time, synchronously or asynchronously, but they're often disconnected that the kids don't know that there's others doing that work. And they may feel like some of these libraries may be smaller spaces where it's like, oh, it's just a couple of us doing this, feeling kind of isolated, right? Well, this can allow you to have recognition or awareness of what others are doing in this real time. It can, again, support these kids to connect to these larger communities. And through all of this, we believe, and we're starting to show through our work, it has more opportunities to share projects, expertise, mentorship, and the impact of the things that they design in these maker spaces, both locally and globally. I'll stop there. Thank you so much for the time, and happy to answer any questions.
Wow, okay. Mike, thank you so much. That was amazing. All of these tools that you've created to connect folks. My mind is blown right now by all of this amazing information. So we have a few minutes for some questions. I don't think I've seen anything in the chat other than a quick one that was answered by Soo-hyun. So please put your questions in chat, or if you can raise your hand, you do have the power to unmute yourself now so you can ask questions. So we will open the floor. I know I had an amazing question for Soo-hyun, and it's completely gone out of my mind now. I'll have to email you later, Soo-hyun, after it comes back to me. Okay, Mike, what materials do libraries need to set up a Reach projector?
So we have like a kit that we've kind of put together and we're hoping to make available writ large. But if you reached out, basically it uses a Arduino or not Arduino, sorry, a Raspberry Pi, small computer, and then an associated camera and projector. One of the things we've been really trying to do is make it low cost so that you could set one up for around $60 each. I think it's probably a little bit more than that, but not a lot more. And
Mhm.
then we have blueprints for laser cutting the sort of stand that holds it together.
Okay, great. Yeah, because I mean, I just I want to, if please raise your hand if you have a question or put it in chat. And but I can imagine, we do through the Core Maker Technology Interest Group, we do tours of maker spaces to kind of connect, and we see that there's a lot of, things that we have in common, a lot of similar projects. But I can just imagine these setups where we're sharing projects. Okay, so Mike, from Cindy Co., I may have missed it. What was the platform you used to set up the CXS dashboard?
Yeah, so it's basically just a web service that we set up and it runs in Firebase. So it's pretty easy to set up if you've got like, you could set it up like on a local server in like, I'll say an hour. But it's all just open source. We built it in Unity for the dashboard. But it's all set up, it's all open source. So and uses Firebase. So once you've got the package, there's nothing you need outside of just web browsers, essentially.
Yeah. I love that it was built during COVID to connect folks who couldn't get together in person, but I think that it's also just an alternate way for students who may not, or anyone, adults who may not feel as comfortable connecting in person. Maybe they just want to connect in a different way. Okay. Any other questions? Okay. I guess, ugh, let me see if I can get my question um, put together for Sue Hyun. In the meantime, while we give everyone a chance to think, we do have a few more 4 minutes. Um, Soo Hyun, I know you were working with like families and children, when you're talking about engineering education. But do you think that's something that could be used with other audiences, other age groups?
Is your question, I just wanted to clarify your question first. Are you asking if the same curriculum could be applied to different age group or
Not
the
exactly the same curriculum, but the same concepts in terms of um, kind of reframing, how folks think about like engineering education.
Mhm. I think it can be applied regardless of your age or it's the culturally relevant ways of approaching or introducing engineering is we've seen that it's applicable to librarians who are adults, parents of various age groups, right, and children. And it's just a more culturally and personally relevant way of understanding engineering because learners get to actually make connections and build new understanding with existing sources of information, right? So something that may have been a foreign concept, a very abstract concept, is now made become made sense because of these building blocks, whether it's a different prior experience or shared knowledge within the family experience, or so using that as a building block to introduce and engage in engineering, I think that can be applicable to regardless of who you are.
Yeah, yeah. Like I'm thinking of using it with college students in terms of kind of connecting it to their prior experience and saying like, oh, like, you've maybe like fixed a car before. You know what I mean? Like you've done this before, you've done this before, then, you um have engaged in this type of thinking and you've engaged in this type of work before. So just kind of like lowering the intimidation factor a little bit. So
I think that's one of the exciting things that we're finding, that lowering that anxiety, and that can be done. That can be done. So that's exciting to see.
yeah, yeah. So great. Okay. Well, I really appreciate all of the presenters today. We all appreciate and we are at time, so I will let you all go and we will see you at the closing session. Thank you.